to my kcse revision channel, Jamari English Voice High School. Kindly subscribe, click the notification bell, such that you get notified once I upload a new video. Today we are looking at a very important part of our kcse. That is a question that was set last year, kcse 2022, paper 1, paper 2, question 1. In paper 2, question 1, aluminium and phosphorus forms oxides with a general formula of M2O3. Complete the table 1 by writing the properties of oxides. So we have a property, then we have aluminium oxide, then we have the phosphorus oxide. We have a structure, bonding, acid base character. A student or a candidate were required to complete this part. So in its structure, aluminium has a giant ionic structure, whereas phosphorus oxide has a simple molecular structure. In bonding, we have aluminium oxide normally has the ionic bonding, and the phosphorus oxide has the covalent bonding. In acid-base character, aluminium has it is amphoteric nature, meaning that it can react with an acid or it can react with a base. And then we have the phosphorus oxide, the acid-base character, it is normally an acid. So simply we have to complete that this one is the structure of aluminium oxide is giant ionic, phosphorus is simple molecular. Bonding, we have this one has ionic bonding. The phosphorus oxide has covalent bonding. Acid-base character, this one is amphoteric. And the phosphorus oxide, this one is acidic. This was a very simple question. The grid in the figure 1 shows part of the periodic table. Use it to answer the question that follows. As you can see, this one is it was a plain grid. So, and it is the simplest question that has ever been set. So, a student who prepared well was to score all the marks in this part. We have been given that give the total number of elements that can be placed in period 1 and period 5. But before that one, the vertical lines, this represents the period and the horizontal represents the group. So this one is group 1, this one is a period 1. So we have this one as period 1, period 2, period 3, period 4, and then we have period 5. We can have this one as group 1, we have group 2, then we have group 3, group 4, group 5, group 6, group 7, and finally we have group 8. So the vertical represents the period, and the horizontal one represents the group. Now place give the total number of elements that can be placed in period 1. We have this one is period 1. So what is the total number of elements that can be placed in period 1? In period 1 now we have the total number of elements. We have 1, 2. This is represents period 1. So the total number of elements is 1, 2. So the total number of elements that can be placed in period 1 is just 2 elements. Now we have period 5. Period 5 we have this is 1, 2, 3, 4, 5. So this is where we have period 5, and the total number of elements that can be placed here we have number 1. So we can count this one as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a total of 18 elements. So we can talk of this one here as 18 elements. Then we have Place each of the following elements in the grid. We have element X whose atomic number is 14. Element X with atomic number of 14, you write the electronic configuration of this one as 2 to 8 to 4. Then you realize that this element X, you can find it in the group 4 of the periodic table. Then we have period 1, 2, 3. So you go to group 4, period 3. We can count this one here. And period 3, we have 1, 2, 3. 1, 2, 3. This is our period 3. Then we go to group 4. Group 4, you can count this is group 1, 2, 3, 4. So element X can just be placed there. Because it has 14 atomic number, so you write the electronic configuration. The outermost number of electrons will give the position of our group of element in the grid, and the number of energy level occupied gives the position of the period of that element in the grid. Element Z with the lowest ionization, we have element Y with the highest ionization energy, and then we have element Z with the lowest ionization energy. So an element Y with the highest ionization energy, and I remember the grid was just plain. So if it was just plain, if you wanted to select an element with the highest ionization energy, you select the element group 8 at the top. So we have group 8 elements at the top, they have the highest ionization energy. So this one here, we can have element Y, because you select an element in group 8 at the top. Element with the lowest ionization energy is the element in group 1 at the bottom. So we can have our element Z here. So we have an element Z there. So in terms of ionization energy, element with the highest ionization energy, you get it at group 8 at the top, and the element with the lowest ionization energy is found in group 1 at the bottom. Then we have element N, whose ion is N2 minus, has an electronic arrangement of 2.8. 2.8, it means that we have this negative. This negative, it means that an element N forms an ion bargaining with the 2 electrons. So if it forms an ion bargaining with the 2 electrons, so the ionic configuration is 2.8. So the atomic configuration will be 2.6. Such that if it gains the 2 electrons, now the ionic configuration will be 2.8. So where do you find this element? The number of energy level occupied is 2, because we have 1, 2. So you go to period 2. In which group? We have group 2 and period 2, group 6. So we can go to period 2. We have, this is period 1, period 2. Then we have group 6. Group 6, we can count this is 1, 2, 3, 4, 5, 6. So we place that element L is placed here. So element N is just placed there. Then we have element D, whose ion D2 plus 2 positive has an electronic arrangement of 2.88. When we have these 2 positive, it means that the element forms an ion by losing the 2 electrons in the outermost energy level. Therefore, if this is the ionic configuration, then the electronic configuration of that element will be, it is 2, 8, then we have 8, then we have 2. That when this element now loses the 2 electrons, it will form an ion of D2 positive with ionic configuration of 2.8.8. Now where do you find this element? You just count the number of energy level occupied, and that is 1, 2, 3, 4. So you go to period 4 group, you look at the number of electrons in the outermost energy level, and that's 2. So we go to group 2, period 4. So group 2, period 4, this is where we have group 2 is here. So we have group 2 is here. Period 4. Period we have 1, 2, 3, 4. So that element D is normally placed there. Then we have an element Q halogen, uh, halogen with the highest atomic radius. An element Q with the an element Q halogen with the highest atomic radius. That element you normally go on halogen. Halogens are the group 7 elements. So you count up to group 7. So we have 1, 2. We have 1, 2, 3, 4, 5, 6, 7. So this is where we can find the halogen. And as we know that the atomic radius increases down the group, so that element must be placed at the bottom of that group 7. And therefore we can have that element is just placed there. We have element R, a period 3 element that exists as a monoatomic gas. Element R, period 3 elements which exist as a monoatomic gas. As you can see, I have placed the group 3 elements here. The group 3 elements, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So what do you need to understand about this element, more especially from phosphorus, sulfur, chlorine, and argon? Phosphorus, so we have this phosphorus. Phosphorus is normally a tetratomic molecule. So this one is tetratomic. It is a tetratomic molecule. It is a tetratomic molecule, meaning that it has 4 molecules. Then we have sulfur. Sulfur is just octatomic. Octatomic. This one is octatomic molecule. Because sulfur normally has the arrangement of 8 rings. Then we have chlorine. Is normally diatomic molecules. So this is a diatomic. This is a diatomic molecule. And then we have argon. It is normally monatomic. So we can have the argon. This one is monoatomic. This is the monatomic molecules. So in period 3 elements, if you can follow this example, we have phosphorus, which is a tetratomic molecule. Then we have sulfur, which is octatomic molecule. Then we have chlorine, which is a diatomic. Then we have argon, which is a monatomic. This one is a very important part because it will assist you to explain the differences in melting and boiling points. Because the higher the number of molecules, when the higher the number of molecules, the higher the melting and boiling points. For instance, here that of these 4 elements, such as phosphorus, sulfur, chlorine, and argon, sulfur has the highest melting point because it has the highest number of molecules. So this one is a very important part which can assist you to answer questions in melting and boiling point. So we will to place element R, which is a period 3 element. So period 3 we have 1, 2, 3. This is where we have period 3, and that element exists as a monatomic gas. A monatomic gas you normally go up to group 8. So you have period 3. We have this period 3, and then you go to the group 8. That is where you can select an element which exists as a monatomic molecule, and therefore that element R is normally placed here. It is normally placed there. This was a very simplest question 1 that was set last year, and a candidate who prepared well scored well at this part. Kindly follow my channel, click the notification bell, subscribe. You get notified once I upload a new video. Thank you.